You know that feeling of solid ground beneath your feet? Stable, solid rock, right? Well, what if I told you that our planet isn't really a rock at all? It's a machine, a massive heat-powered engine that's constantly moving, constantly shaping our world in ways we can see and feel every single day.
I mean, we see the evidence all the time. Earthquakes that shake cities, volcanoes that erupt with unbelievable force. So it really makes you wonder, what's driving all of this incredible power? What kind of engine is strong enough to literally move continents?
Well, the answer isn't anywhere on the surface. To find it, we've got to go on a journey 4,000 miles straight down to the very heart of our planet.
So let's break this thing down. We're going to explore this Earth machine, looking at all its parts from the outside all the way in.
Our journey starts right here, where we are, on the crust.
And here's a wild way to think about it. If the Earth were an apple, the entire crust, that's everything we live on, the oceans, the mountains, the whole deal, would be no thicker than the skin of that apple. It's an unbelievably thin, fragile layer.
So let's take a closer look at this restless crust. This is where we see the most dramatic, the most visible effects of the machine churning away far, far below us.
You see, that fragile apple skin, it's not one solid piece. It's actually fractured into about 14 enormous tectonic plates. And these plates aren't just sitting still, they're literally floating on top of the hot, flowing mantle beneath them, constantly grinding against each other, moving as fast as 6 inches a year.
So what happens when 2 of these giant plates get stuck?
Well, the pressure just starts to build and build and build, sometimes for centuries. Then, all at once, all of that stored up energy is released in a single violent snap. And that is what a massive earthquake is. It's that simple and that terrifying.
And listen, this isn't just a theory. Geologists like Roland Bergman are watching this happen in real time. They are monitoring faults like the Hayward Fault in California right now. They can actually measure the pressure building up. They know it's not a question of if the plates will slip, but when. If you want a stunning, real-world consequence of this, get this number: $320 million. That's how much it costs to retrofit a football stadium at the University of California. Why? Because the Hayward Fault runs directly underneath it, from goalpost to goalpost. They had to literally saw the stadium in 2 so each half can move when the big one finally hits.
Now, plates sliding past each other cause earthquakes, but when they collide head-on, the results are just as huge. All that immense force has nowhere to go but up, buckling the Earth's crust and forging entire mountain ranges.
And this power is just relentless. It's always happening. Take Mount Everest. It was formed when the Indian plate slammed into the Asian plate. And because those 2 plates are still pushing into each other, Everest is still growing by about 0.2 of an inch every single year. So we've seen the effects on the crust, earthquakes and mountains. But what's actually powering it all? To answer that, we have to go deeper. We're heading into the engine room of the planet.
Right below that thin crust is the mantle, this huge furnace of molten rock. But below that, we finally get to the planet's core. And this is it. This is the true engine room. It's where the real power of the Earth machine is generated. But to understand its power, let me ask you a kind of strange question. How does a tiny loggerhead turtle manage to navigate the entire Atlantic Ocean and then return to the exact beach where it was born? What does that have to do with anything?
Well, the answer lies in something you can't even see: the Earth's magnetic field. It's this invisible shield that's generated by the churning, molten metal of the outer core. It stretches tens of thousands of miles out into space and protects us. But it also does something else.
As scientists like Ken Lohman discovered, these turtles can actually sense that magnetic field. It's like they have a built-in biological GPS system that's powered by the very core of the Earth itself. It's an incredible link between the deepest parts of our planet and life on the surface.
But as amazing as that is, guiding turtles isn't the core's main job. Not even close. Its most important function, the ultimate power source for the entire planet, lies at the very, very center, the final stop on our journey.
We've finally reached it, the inner core. It's a solid ball of metal crushed by pressures that are impossible to imagine. And its temperature? It's the same as the surface of the sun, a staggering 6,000 degrees Celsius. This is the ultimate power source.
So, how does this super hot ball of metal actually power everything we've just talked about? Well, in this last part, we're going to see exactly how that heat forges our planet's future. Here's how the whole machine works. That incredible heat from the inner core rises up through the mantle in these giant plumes. When the plumes hit the bottom of the crust, they spread out and they push the tectonic plates around like rafts on a boiling pot of water. Then, that material cools, it sinks back down toward the core, and the whole cycle starts all over again. It's one giant planetary engine. And the long-term result of this engine is, well, it's pretty mind-bending. Scientists believe this cycle is going to keep pushing the continents around until about 250 million years from now, they'll all merge back together into a single giant supercontinent. Los Angeles and Tokyo could be neighbors one day. So from earthquakes and mountains to the incredible journey of a single turtle, it's all powered by this fiery engine 4,000 miles beneath our feet. The Earth machine never stops. It's always working. Which leaves us with one final amazing thought. What unimaginable landscapes is it quietly creating for our future, right now, deep down in the dark?